Hey, let's look at solving equations using the elimination method, and in this video we're going to be using multiplication to eliminate. Alright, so remember, in some systems there are not similar coefficients like we talked about in the previous video. So in these cases you'll need to multiply one equation or both equations by some number so you can eliminate one of the variables. So let's look at our first example. We have 2x plus y equals 5 and 3x minus 2y equals 4. Notice no of the coefficients and variables line up. They're not the same. So they will not cancel with adding or subtraction, so we must multiply. What you want to find is basically a common factor, almost like finding a common denominator. So what I need to do is somehow find out how can I eliminate one of these variables. Well, I know that if I multiply this top one by 2, then I would have 2y here, and I can have negative 2y here, and this will cancel. So what I'm going to do is multiply this whole top equation by 2. I distribute 2 times 2x is 4x, 2 times y is 2y, and 2 times 5 is 10. Now it lines up so the 2y and the negative 2y will cancel out if I just add my two equations. Now you can also just multiply the top and bottom by something to get rid of the x. Either way you want to work it, it's just this is easier because I only have to multiply one equation. Alright, so 4x and 3x added together I get 7x. 2y and negative 2y added together, remember, cancel out. And 10 plus 4 is going to give me 14. Now I'm going to divide each side by 7, and x is going to equal 2. So there's my x value. Now remember, substitute your x value in to one of the equations and solve for y. So in the first one, 2x plus y equals 5, I put in 2 for y, or excuse me, 2 for x. 2 times 2 is 4. 4 plus y equals 5. Subtract 4 from both sides, and you're going to get y to equal 1. So my solution to this problem is 2, 1. Now let's look at another one, because sometimes it takes a few of these examples to totally understand. Now we have the system negative 2x plus 15 equals negative 32, and 7x minus 5y equals 17. Alright, now if you look at this, none of the coefficients and variables line up to where if you add or subtract the equations, that one of them will cancel out. So I've got to think, what can I multiply one of the equations by to cancel one of the variables out? Now we're lucky with this one where we can just multiply one. Sometimes we'll have to multiply both the equations. Now, first off you need to decide, okay, can I easily get rid of the y or the x? Well, in this case, if you need to get rid of x, 7 and negative 2, you're going to have to multiply both equations. Now you can do that, or you can get rid of the y, and notice I have 15y up here. Well, 5 goes into 15 3 times. So if I multiply this whole bottom equation by 3, I can cancel out my y's by adding them. So I do 3 times 7x, which is 21x, 3 times minus 5y, which is minus 15y, and 3 times 17, which is 51. So when I add these, negative 2x plus 21x is 19x, 15y minus 15y, that goes away, and negative 32 plus 51 is 19. Divide each side by 19 and I get x equals to 1. So we've got our x value. Now take one of the equations, substitute 1 in for x and solve for y. So I did it in the first equation. So negative 2 times 1 is negative 2. Then I add 2 to both sides. Negative 32 plus 2 is negative 30. So I have 15y equals negative 30. Divide each side by 15, and I get y equal negative 2. So my solution for this system is going to be 1, negative 2. Alright, now sometimes I will say you will need to multiply both equations in order to eliminate a variable. So if we look at this one, 4x plus 2y equals 14, and 7x minus 3y equals negative 8. Now, none of these I can multiply just one equation in order to get rid of a variable. So I'm going to have to multiply both equations. Now you can either get rid of x or get rid of y. It doesn't matter whichever one you feel comfortable with. In this one, I'm going to try and get rid of my y's. So 2 and 3 have a common term of 6. They both go into 6. So what I'm going to do is the top equation, in order to add these two together for them to equal 0, the top one needs to be multiplied by 3, the bottom by 2. When I do that, remember I do 3 times 4x, 3 times 2y, 3 times 14. Then I do 2 times 7, 2 times negative 3y, 2 times negative 8. And this is what you come up with over here. 12x plus 6y equals 42. And 14x minus 6y equals negative 16. Okay, when I add these two together, 12x and 14x is 26x. 6y and negative 6y go away, they eliminate. 42 plus negative 16 is a positive 26. Divide each side by 26 and you get x to equal 1. Again, substitute the x value in for y and solve. So 4x plus 2y equals 14. I'm going to use the first equation. Remember, I've told you before, it doesn't matter which equation you substitute it in for. So 4 times 1 is 4. Then I've got 4 plus 2y equals 14. Subtract 4 from both sides. I have, this is supposed to be 2y equals 10. Divide each side by a 2. Sorry, it kind of has erased. Okay, 10 divided by 2 is 5. So my solution is going to be 1, 5. Alright, let's look at one last equation before we are done. Alright, so this system, 3x minus 7y equals negative 26. And 2x minus 5y equals negative 20. Now, if you notice again, none of them can be added or subtracted and a variable eliminated. Also, I'm going to have to multiply both equations in order to eliminate a variable. Now, let's say I want to get rid of x. Now, you can choose to get rid of y, and that's perfectly fine. Notice both of these are pluses. So if I added them, then it wouldn't eliminate it. If I subtract them, and it wouldn't eliminate it. Or it wouldn't. So I need to multiply one or the other, or both, by a number. Now, I'm going to do the top by 2, so this becomes 6x. And the bottom by negative 3, so this becomes negative 6x. That way, since adding is easier, these will actually eliminate. So that's why I've added in the negative 3. So once you distribute, you come over here, you get 6x minus 14y equals negative 52. And negative 6x plus 15y equals 60. Okay, let's add them. 6x plus negative 6x. This eliminates. Negative 14y plus 15y gives me y. And negative 52 plus 60 gives me 8. Easy, we're done. We've already got y equals 8. So I take that, plug it in, and like I said, first or second equation, it never really matters. So I take my first one, 3x minus 7y equals negative 26. Put in 8 for y this time. 7 times 8 is 56. Add 56 to both sides. Negative 26 plus 56 gives me 30. So I have 3x equals 30. And divide each side by 3. I'm left with x equals 10. So my solution is 10, 8. And that is my solution coordinate point.